Hello everyone, welcome to this advanced problem solving series from IIT. So here this is a problem from Fiji All India Test Series. Uh, See, in the shown figure, a plank P of mass 25 kg. This is a plank P of mass 25 kg is placed over a cylinder C of mass 10 kg. The cylinder is placed over a block B, that's block B, of mass 5 kg. All the surfaces are rough and coefficient of friction between all surfaces is mu equal to 0.3. What is the minimum horizontal force F needed to pull the block? Plank is hinged at A so that it is free to move in vertical plane without friction. Now, if you have to just move this block, that means at this surface, limiting friction will be acting. That means if the normal reaction here is n, then mu times n will be acting that way. Just showing here this direction, mu times n, normal reaction, the limiting friction will be surely acting, where n is the normal reaction on the plank B or on the block B, whatever you say. Now let's look at the cylinder. Now here lies the trick to solving this problem. If you look at the cylinder C, let us look at friction acting on the cylinder C. Suppose we consider friction acting on the cylinder C is F to the right. Then see, in this situation the force applied is just to move the block. That means it is just on the verge of slipping. The block B is just on the verge of slipping with ground below. So that means the system is still at rest and its acceleration is also zero. Now if you look at cylinder C, now the force of friction is F, this one. Suppose now to keep the linear action, to have the linear acceleration of the center of mass of this cylinder C 0, there will be friction acting in this direction, F. Well and good. But what happens if friction acts like this way? Friction at the lower surface F to the right and the upper surface F to the left. Then if you calculate torque from center of mass of this cylinder C, there will be unbalanced torque, and this proves that there will be angular acceleration alpha. Now, so you can say, okay, so we do not want any angular acceleration alpha. ठीक है. So if you do not like this alpha to happen, that means friction has to be this way. Now again, if friction on the on the top surface is to the right, so alpha is 0. But what about the linear acceleration of center of mass? Then the net force acting is 2F. So there is only one option, only one thing is possible, that is the friction is 0. That means on this cylinder C there is no friction acting, right? That means that is sure that friction acting on the cylinder F is equal to 0. Now let's look at the normal reaction. Say from the top, normal reaction is N1, and here is the weight of the cylinder. What is that? Weight of the cylinder is 100 Newton, and here N2. So actually N1 plus 100 equal to N2. N1 plus 100 is equal to N2. That's okay. What's N1? To find out this N1, you know the same normal reaction will be acting upward on the plank P. So now we can balance torque. So for the plank P, what's the weight? 250, right? 250 Newton. So what is the distance? The total, the length is 4, so that's 2. So 2 into 250. So if you balance torque for P, for P, the resultant torque is equal to 0. Therefore, we can write 250 multiplied by 2 equal to N1 multiplied by 3. So therefore N1 equal to 500 divided by 3, this much Newton. Okay, so again let's go back to the cylinder. So N1 we have found out, 500 by 3. So what is N2 now? So N2 equal to 500 by 3 plus 100. So that means it is 800 by 3. 800 by 3. Okay. Now at last let's look at the block B. So there the force is equal to N2 or what? Yeah, N2. So this is N2, which is equal to 800 by 3, and here you have mass. Mass is 5, so 50, and there you have the normal reaction at the ground N, and there you have mu N. Mu is 0.3, so 0.3 times N, and the force, minimum force needed to pull F, is also equal to just 0.3 times N. So you have to find out N. So if you balance the forces vertically on the block B, you find N is equal to 50 plus 800 by 3. That means it is 50, so 950 by 3. So normal reaction is 950 by 3. Therefore the force is 0.3 times N. So 0.3 times 950 by 3, that means equal to 95 Newton.